Hello dear student, myself Hrishikesh Labhade. I am working as an assistant professor in Srimati Vimla Ben Khimji Tejokia College, Devrali Camp, Nasik. I welcome you all in this online LMS lecture series. Today we are going to learn about chemical energetics. This topic includes in Sri Savitribai Phule Pune University's first year BSc semester 1 physical chemistry course. Session agenda. In today's lecture, students gonna learn about objective of thermodynamics, limitations of thermodynamics, and also certain thermodynamics terms such as system and surroundings, open, closed and isolated system, homogeneous and heterogeneous system, macroscopic system and properties, some state of system and state variables. Student also gonna learn about extensive and intensive properties with their example thermodynamic equilibrium and thermodynamic process. In today's session, we are also going to study about zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics and standard state. We will end today's session with the problems on enthalpy of formation, enthalpy of combustion. So let's get started. Learning objective. In today's session, student will understand objectives and limitation of thermodynamics as well as some basic terms related to thermodynamics. Student will also learn zeroth law, first law and second law of thermodynamics and can also be able to apply thermodynamic principle to physical and chemical processes. With that, we will get started. Objective of thermodynamics. Thermo, as word suggests, thermo means heat and dynamics means motions or mechanical work. Hence, thermodynamics is a branch of science that deals with the conversion of heat into mechanical work or vice versa. In wider sense, it is a branch of science that deals with the quantitative relationship between heat and other form of energy. Objective of thermodynamics. The first objective is to predict the feasibility of the process. Whether or not the process will occur under a given condition can be predicted by applying principle of thermodynamics. The second objective is to estimate the yield of products. The thermodynamics helps to predict yield of the product in the reaction by knowing up to which extent the reaction takes place before attaining the equilibrium. Third objective is to deduce some important relationship. By using thermodynamics, we can deduce important and useful relations such as Raoult's law of lowering vapor pressure, expression of depression in freezing point, elevation in boiling point, and distribution law and phase rule. The second topic in today's lecture is limitation of thermodynamics. There are certain limitations to thermodynamics. The first is study properties like pressure, volume, temperature on only macroscopic quantities, that is large group of ions, molecules and atoms, and not on the microscopic quantities such as individual atoms, individual ions or molecules. The second limitation to the thermodynamics is predict the feasibility of a reaction but gives no idea about the time taken for the reaction to proceed. The third limitation of thermodynamics is treatment is only limited to the initial state and final state and not on the path which is followed throughout the reaction. Now we are going to learn about some important terms in thermodynamics. The first is system and surrounding. System, the part of universe considered for the thermodynamic studies is known as system. For example, if it is a piston with a container filled with the gas, we are going to study, then it is the system, and the surrounding is a rest of a part of the universe excluding the system. Now, second is open, closed and isolated system. Open system, a system which can exchange both matter and energy with the surrounding, it is known as open system. The example in this category is hot tea in a cup and saucer. Here both the matter as well as energy is exchanged between the surroundings. Closed system, A system which can exchange only energy with the surrounding but not matter is known as closed system. Example is water placed in a closed metallic vessel, so no exchange of matter occurs, but the conducting wall of the vessel can exchange the energy. The general example is hot tea in a cup and saucer, but the cup is covered with the lid. Third is isolated system. A system which cannot exchange neither energy nor matter with the surrounding is known as isolated system. Example in this category is water placed in a vessel which is closed and having insulated walls. A thermos flask is one of the example in the isolated system. As students should note that no perfect isolated system can exist, because the minimum amount of energy can be exchanged how much you try. Homogeneous and heterogeneous system. Homogeneous system. The system which is uniform throughout is known as homogeneous system. It has only one phase. The example in homogeneous system is a mixture of gases or a pure liquid or pure solid. Now second is heterogeneous system. The system which is not uniform throughout the experiment and has a two or more phases is known as heterogeneous system. The example in this category is system consists of liquid and its vapor or two or more immiscible liquids. Macroscopic system and macroscopic properties. Macroscopic system. It is a system consisting of a large number of particles, that is atoms, ions or molecules. And macroscopic properties. Properties related to the behavior of particles in a macroscopic system, that is pressure, volume, temperature, density, viscosity, surface tension, etc. Next point is a state of a system and state variables. State of the system. The state of a system means a condition of a system when the various macroscopic properties such as pressure, volume, temperature, etc. have been assigned to definite values. The first and latest state of the system is called as initial state and final state, as we know. State variables. Macroscopic properties are known as state variables. The most common are pressure, volume, temperature and composition of the system. Now we are going to learn about thermodynamics equilibrium. A system is said to be thermodynamic equilibrium if the macroscopic properties of a system in a various phases do not show any variation with the time. Thermodynamic equilibrium implies the following three equilibria must exist. First is thermal equilibrium. Implies that there should be no flow of heat from one portion of the system to another portion. It is possible when the temperature of system remains constant. The second equilibrium is mechanical equilibrium. Implies that no work should be done by one part of a system over another, or no macroscopic movement of matter should take place within the system with respect to its surrounding. It is achieved when the pressure of a system remains constant. Chemical equilibrium. The equilibrium implies that no change in a composition should occur in any part of a system over the passage of time. So we learn about three equilibrium in thermodynamics. Now the next point is extensive and intensive properties. What is extensive properties? Properties which depend upon the quantity of matter contained in the system are called as extensive properties. Example in this category is mass, volume, energy, heat capacity, etc. The net value of an extensive property is equal to sum of total of value of separate parts into which the system may be divided. Intensive properties. Properties which are dependent only upon the nature of substance and are independent on the amount of a substance present in the system is called as intensive properties. Example in intensive properties are temperature, pressure, refractive index, viscosity, density, surface tension, specific etc. Interestingly, an extensive property may become intensive property by specifying unit amount of the substance. Thus, the mass and volume are extensive properties, but density is an intensive properties. Heat capacity is an extensive properties, but the specific heat is an intensive properties. Now we are going to learn about thermodynamic process. First is isothermal process. As the name suggests, if the process is carried out in such a manner that temperature remain constant throughout the experiment or throughout the process, it is called as isothermal process. In such a process, heat can flow from system to surrounding or vice versa to keep the temperature of the system remains constant. Second is adiabatic process. If the process is carried out in such a manner that no heat flows from system to surrounding or surrounding to system, or the system is completely insulated from the surrounding, it is called as adiabatic process. Third is isochoric process. A process involves no change in the volume of the system, it is known as isobaric process. Isochoric process. Isobaric process, a process which involves no change in the pressure of the system, it is known as isobaric process. Now next important point is reversible process. Process which is carried out infinitesimally slowly such that all change occurring in the direct process can be exactly reversed and the system appears to be at the state of equilibrium in each moment. A reversible process is almost impossible as it would require an infinite time for the completion. But a process can be made nearly reversible in some cases. For example, if the opposing electromotive force is exactly equal to that of cell, then no current flows from the electric circuit. If the opposing EMF is very slightly less than that of the cell, a very small current is given out by the cell. Exactly opposite, if the opposing EMF is slightly greater than that of the cell, a very small current flows but in the opposite direction. A reversible process demonstrated by the following experiment. Take a cylinder having a frictionless piston containing a gas at a moderate pressure. Due to this pressure, the piston will start rising upwards. Now we will place a petri dish or a container containing a fine sand particles over the pistons. In a balanced position, the piston is in static. That is no movement in the static position. That is no movement of piston will take place. Now, if we add a very small sand grain on the petri dish, due to the pressure, the pistons will start moving downwards, but very slowly. On the other hand, if we take out a very small sand grain from the petri dish, the piston will start moving upwards very slowly due to pressure of the gas. In these both cases, it is demonstrated the reversible process. We can see the experiment diagram in the image given below. Irreversible process. Process which is not carried out infinitesimally slowly so that the successive step of direct process cannot be retraced and any change in the external condition disturbs the equilibrium. An irreversible process occurs when carried out rapidly. The example of irreversible process are all naturally occurring process like flow of water from down to hill to bottom, heat transfer from hot end to cold end of an iron bar are some thermodynamics irreversible processes. Now we are going to see about laws of thermodynamics. The first law is zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two bodies are in thermal equilibrium with some third body, then they are also in equilibrium with each other. For example, consider a body A is in thermal equilibrium with another body B and also separately in thermal equilibrium with the body C. Then body B and C are also in thermal equilibrium with each other. This thermodynamic zeroth law is based on the temperature measurement. The another statement for the zeroth law of thermodynamics is that the systems that are in thermal equilibrium exist at the same temperature. First law of thermodynamics. There are many statements for first law of thermodynamics, but the most popular one is energy can neither be created nor be destroyed, although it may be converted from one form to another. The second statement is the total energy of an isolated system remains constant, although it may undergo transformation from one form to over another. The third statement is, whenever certain quantity of some energy is disappeared, the exact quantity of amount, exact quantity equivalent amount of some other form of energy must be produced. The fourth statement is, it is impossible to construct a perpetual machine. A perpetual machine is a machine that produces work continuously without consuming energy. Mathematical formulation of first law of thermodynamics. If a heat which is represented by Q is supplied to a system, it may be used partly to increase the internal energy of system and partly to do some mechanical work. If delta U is the increasing internal energy of a system and W is the work done by the system, then we get the equation as delta U equals to Q plus W. If the work done is a work of expansion, then W equals to minus P delta V. Now by substituting and some rearrangement, we will get the final equation as Q equals to delta U plus P delta V. Second law of thermodynamics. There are various statements for the second law of thermodynamics. Some of them are as follows. The first statement, the complete conversion of heat into work is impossible without leaving some effect elsewhere. The second statement is, it is impossible to construct a machine functioning in cycles which can convert heat completely into equivalent amount of work without producing a change anywhere else. The third statement is, without the use of external agency, heat cannot by itself pass from colder body to hotter body. Standard state. A standard molar enthalpy of every element at 1 atmospheric pressure and 298.15 Kelvin in the most stable state is taken as a 0. This condition of 1 atmospheric pressure and 298.15 Kelvin temperature, it is known as standard state condition. It is not possible to determine absolute value of molar enthalpy, but we can use above convection to find the standard molar enthalpy of a substance. The most stable form of hydrogen, that is gaseous hydrogen, liquid bromine and solid iodine, their molar standard enthalpies are taken as 0 at 1 atmospheric pressure and 298.15 Kelvin temperature. In case of elements exhibiting allotropy, we consider the most stable form under the condition of standard state. First is heat or enthalpy of formation. The enthalpy of formation of a substance, it is defined as heat change takes place when 1 mole of substance is formed from its elements under the given condition of temperature and pressure. It is represented by delta HF. Second is standard enthalpy of formation. It is defined as a heat change accompanying in the formation of 1 mole of substance in the standard state from its element are taken in the standard state, that is 298 Kelvin temperature and 1 atmospheric pressure. It is usually represented by delta HF but not delta H nod F. The nod represents the standard state. For example, carbon plus oxygen giving a carbon dioxide. When 1 mole of carbon dioxide gas is formed from its element, that is carbon and oxygen in the gaseous standard state, 393.5 kilojoule of heat is produced. Hence, the standard heat of formation of gaseous CO2 is 393.5 kilojoule per mole. Knowing the standard enthalpy of formation of compounds involved in the reaction, we can then obtain the standard enthalpy change during a reaction. The formula for this is delta H naught of a reaction equals to sum of standard heat of formation of products minus sum of standard heat of formation of reactant. In general, for the given reaction, we will take the standard heat of formation of C and D, the product, multiplying by their respective moles minus the standard heat of formation of reactant. Delta H naught is taken as a 0 for the elements in the reaction. Standard enthalpy of combustion. It is defined as amount of heat evolved or absorbed when 1 mole of substance in the standard condition of 298.15 Kelvin and 1 atmospheric pressure burned completely to form a product under these conditions. It is represented by delta H naught C. For example, the combustion of methane to give carbon dioxide and water as shown in the reaction, the enthalpy of combustion is minus 890 kilojoule per mole. Now we will discuss some problems regarding the enthalpies of formation. The first problem is enthalpy of formation of CO2 gas and H2O liquid under the standard condition are 394.65 kilojoule and 285.84 kilojoule per mole. If the standard enthalpy of combustion of acetaldehyde is 116 kilojoule per mole, then we have to find the enthalpy of formation. We will write down the reaction and their respected enthalpies at the right hand side. Then by some rearrangement, we will get the acetaldehyde with acetaldehyde reaction giving carbon dioxide and water molecule. Then just by substituting the values given to our enthalpy of formation formula, that is enthalpy of formation of reaction is equals to the standard heat of product minus standard enthalpy of reactant. We will get the enthalpy of formation of acetaldehyde equals to minus 193.36 kilojoule. The second problem is calculate the delta H naught of a given reaction. We will get the standard delta HF for CO2, carbon dioxide, carbon monoxide and water as minus 393, minus 11.3 and minus 241.8 kilojoule mole inverse respectively. Then as we substitute the values in the formula, and we will get the final answer as plus 40.4 kilojoule. We should note that the enthalpy of every element in the standard state is assumed as 0. Similarly, we will do the third problem. Just by substituting and solving, we will get the answer. Students should try this at home. Student assignment. First is point out the main difference between open, closed and isolated system, and also the second is reversible and irreversible process. The second question is define thermodynamics and what are their main objective. The third question, student have to distinguish between isothermal and adiabatic process. Fourth question is what is intensive and extensive properties and give 3 examples in each category. Fifth question is give the brief objective and limitation of thermodynamics. Sixth is state the first law of thermodynamics in various ways. Seventh is define zeroth law of thermodynamics. And last question is define standard enthalpy of formation and standard enthalpy of combustion. Summary. In today's lecture, we will discuss discussed objective of thermodynamics, that is to predict the feasibility of the process, to estimate the yield of the products and to deduce some important relationships. Later we will discuss the limitations of thermodynamics. Thermodynamics is only for the macroscopic quantities and not for microscopic quantities. The second limitation is it gives no idea about the time taken or rate at which the reaction is proceed. The third is it is only consider the initial and final state of the process and not about the path which is followed. The first then we will we discuss some important terms such as system and surrounding. The system is the part of a universe considered for the thermodynamic studies. The surroundings is a rest of a part of the universe excluding the system. Open system. Open system exchange both energy and matter with the surrounding. Closed system only exchange energy with the surrounding and not matter. The isolated system, which is an example of thermoplast, it does neither exchange energy nor matter with the surrounding. Then we will discuss some processes of thermodynamics. The first is isothermal process. In this process, the temperature of the system remains constant. Second is adiabatic process, process in which no heat flows from the system to surrounding or vice versa. Isochoric process, a process involves no change in the volume. And isobaric process is a process in which no change of pressure occurred. Then we discussed about zeroth law of thermodynamics, which state that if two bodies are in thermal equilibrium with third body, then they are also in equilibrium with each other. First law of thermodynamics, energy can neither be created nor destroyed, it only converts from one form to another form. The second law of thermodynamics, the complete conversion of a heat into work is impossible without leaving some effect anywhere else. Then we discussed about enthalpy of formation of a substance, which is defined as the heat change takes place when 1 mole of substance is formed from its elements under the given set of conditions of temperature and pressure. Standard enthalpy of condition, it is defined as the amount of heat evolved or absorbed when 1 mole of substance under the standard condition is burned completely to products. Recap. In next lecture, we are gonna continue our standard state topic with enthalpy of neutralization, enthalpy of solution, integral heat of solution, differential heat of solution, then heat of hydration, heat of fusion, heat of vaporization, and heat of sublimation. Then we will in the next lecture study about bond energy or enthalpy, resonance energy. Then we will discuss about important law, that is Kirchhoff's law, consisting of two cases. The case 1 is a reaction is carried out at a constant pressure, and case 2, what if the reaction is carried out at constant volume. Then we will discuss about a third law of thermodynamics, and we will study the problem based on the third law of thermodynamics. Thank you.